Hi everybody, Patrick here from EngineeringShock.com and ElectronicLessons.com. Today we're going to show you how to put together one of our new solar tracker kits. As you can see, it comes with two PCBs, a stepper motor driver board, a program microcontroller and socket, a 2-pin terminal block, 7805 5-volt regulator, 100 microfarad electrolytic capacitor, 0.1 microfarad ceramic capacitor, push button switch, 3 LDRs, 5 10k ohm resistors, a bunch of wire, and some hard gauge wire, or some thicker gauge wire. Though this will be used for our stepper and our whiskers, but we'll get to that a little bit later. So first of all, we're going to fully assemble our main driver board and sensor board, and once we're done that, we're going to have to manipulate our sensor board and solder in our LDRs and our resistors. From there, we need to plug it all in and test it, and then we can really set it up so it will look something like this. So let's start with our main board. I'm going to try to get through the main board in 2 steps, so please follow along and pay close attention. 2 of your 10k ohm resistors will be placed on the main board. They're the only 2 resistors on the main board. They are R1 and R2, which are labeled 10k R2, 10k R1. So there's no polarity on resistors, so you can solder them in either way. Your button really only fits in one way, and it goes into the cell slot right here, SEL. It should pop in quite easily. Line up the 4 holes, pop it in, and make sure it's flush to the board when you solder it. Your single ceramic capacitor, 0.1 microfarad, goes in the C2 slot. It's not polarized. There's no positive or negative, so place it in either way. It's labeled C2 0.1. Your 7805 regulator. The front has writing on it. The back has essentially ground, white. Line up the backing with the white on the footprint right here for IC2 7805. Make sure that the writing is facing the front. So in this configuration, solder that into place. Your 2-pin terminal block. There is a 2-pin terminal side, and then there is a plastic side. Make sure that you place your screw terminals facing outwards like this. Your electrolytic capacitor, your 100 microfarad electrolytic capacitor. The slot is C1, 100U for 100 micro. There's a long lead and there is a short lead. The long lead goes into the rightmost hole. There's a little plus sign here on the right side. Make sure not to turn this around. You want long lead on the right, short lead negative on the left. So let's solder those all into place. Next we will do our socket and our driver board. Might be a little bit difficult to see from this perspective, but I think we can manage. The socket is placed into the PIC 18F1220 slot. There's a notch on the left side of the socket, and there's a notch on the left side of the footprint. Make sure that they match from a bird's eye view. Alternately, the chip that's going to sit in the socket has a notch on the left-hand side as well. Make sure that the notch is facing the left-hand side. If you turn that around, you're likely going to destroy your chip as soon as you power it up. Now your driver board. On the inside of the driver board, there is our labels: ground in 4 and 3 and 2 and 1 and VDD. And on the board, I've matched those, so you can match them up. I mean, really, all you need to do is make sure that the white plug is facing the bottom of the board and not facing outwards. If you have it soldered in like this, you've got it wrong. You want to make sure that it's soldered just like this. And there's also a bunch of header pins to the right of it. We're going to use those a little bit later. So I'm going to solder these into place, and you'll see what the board's going to look like when it's done. When all is said and done, your board should look like this. Now, you notice I have some scrap here. That's from the resistors and whatnot. Keep the long ones. Keep the long ones because you're going to need them. You can use some of your solid wire for the next step, but it's probably better that you use some of the thinner stuff. So right now we're going to be looking at this board, the sensor board. Now you'll notice that there are big pads on the left and right side, 8 on the right and left sides. The those pads are basically connector pads. And you'll notice there's a line in the middle on both sides. That's a cutting line. Now, you don't have to cut it, but I highly suggest that what you do is you take a hacksaw, or probably a much better idea would be to take a Dremel tool. Knives won't work on this PC because it's thick. So what you need to do is you need to cut this part of the board off and this part of the board off. So you basically got 3 circuit boards. And I'll show you. Mine actually looks pretty rough because I used a knife. So just going about it, telling you from my personal experience, don't use a knife. Use a Dremel tool, and if you don't have a Dremel tool, use a hacksaw. But again, you have to line it up very, very carefully. So once you're done cutting those, turn the video back on, and we'll keep going. Now, because I hurried and used a knife, you'll see I have a little bit of damage here, but the traces aren't damaged, so it's okay. It's just cosmetic. And this is why I'm saying is you don't want your solar tracker to be cosmetically unsound. So use a Dremel tool or a handsaw and very carefully cut it so it's nice and neat. Now I've turned it around, and I've got the assembled version here, obviously the one PCB, and then my cut PCB right here. What you want to do is you want to reconnect the board by adding little wires to short all of these pads together. So 8 shorts in total. 1, 2, 3, 4, 5, 6, 7, 8. And what this will allow us to do is it'll allow us to bend the board out to the side a bit, so that you get more of a view rather than just a flat view. You're able to put the side LDRs at an angle. Now that'll make more sense in a minute, but for the meantime, just take your strong wire and make those shorts. And if you're still confused as to what I mean, then just wait a minute and I'll show you, because I'm going to be doing this myself along with you. Good as new, huh? So now we want to place our LDRs and our remaining 310K resistors into the board. The resistors are right here, R1, R2, and R3, and the LDRs are LDR1, LDR2, LDR, and LDR. Neither of them have any polarity, so you can place them in either way. Just make sure that these are relatively flush to the board. Same with the resistors, just to make it look neat. Now, the neat thing is now that I've soldered those shorts on, I can bend out the sides of the boards, so I can fiddle with the solar tracker when it's running. So let's solder those into place, and then we will interface our main board to our sensor board and put the motor in. This is what your board should look like when it's done. Time to get out your trusty ruler. I've included some wire. You don't have to use it. You can use your own. It's not stranded. Stranded might be a little bit better, but it's got to be a very thin gauge. This is going to provide the feedback lines from our sensor board to our main board. Now, what you want to do is you want to cut out 6 pieces of wire that are equal in length, about 5 or 6 inches, roughly, depending. It can be longer. It can be 12 inches, but you'll run out of wire. Anyway, on the main board, you can't see it right here, but on the left there's VDD, which is 5 volts, ground, whisk, W-H-I-S-K for whisker, in A, in B, in C. On the back of the sensor board, VCC, ground, ground, whisk, out A, out B, out C. What you want to do is, there's 2 grounds on here for a reason. You only need one of them for now. Connect VDD to VDD, or rather, VDD to VCC. Sorry about that. VDD is commonly used as a 5-volt line. VCC is as well. So VDD to VCC, ground to ground, doesn't matter which one. Whisk to whisk. In A to out A. In B to out B. And in C to out C. So once you've soldered those all in, what we can do is we can plug in our motor and we can run a quick test before we keep going. So I'll actually show you what mine looks like prior to powering it up for the first time. So it's one big mess of wires right now. As you can see, I've plugged in my stepper motor into the driver board. It only fits in one way, so you shouldn't have much to worry about there. If you have a cable tie, or perhaps even some thread, it's nice to kind of neaten this up. So right now, what I did was I applied 9 volts to my board. First thing I did, you can turn it on and off by pressing the select button. It's the select button on the board. Now it won't do anything, the motor won't do anything if there's not enough light touching the sensor board. And right now, since it's relatively dark in here, I'm going to bring up my supercapacitor flashlight and we'll see if it moves. And it is moving. It takes small steps, so it won't be. It's hard to tell from this perspective because the gear head is so small and it's taking single steps because it's trying to be precision. But the feedback is coming from the sensors, and it determines which direction is receiving the least or the most amount of light, and it will track it. So to give a better test, what we'll have to do is we'll have to mount this. Now, what you see here, not including the whiskers, which we'll get to in a few minutes, is what comes with the kit. So you have to be a bit constructive here. Let me show you what I did for the next step. Now this is a completed module, or a completed kit that I've put together. Obviously it's nice and it's neat. There's cable ties. It's got its whiskers on its stoppers. Again, we haven't gotten to that just yet. I've got everything glued down to the board. What I've done here is actually put a second layer so that I could put my stepper motor at a roughly 40-degree angle. Maybe not 40, maybe 30-degree angle. You can have it at 40 degrees or 45, but this is where you're going to have to be a little bit industrious and imaginative. What I'm going to do is I'm going to reuse this board and mount my new set exactly as I have done it here, and I'm going to put on the whiskers and I'm going to put on the stopper. Okay, so what I'm going to do is I'm going to go through this in one big step, and well, not one big step, two little steps rather. Just follow along. You don't have to do it this way, but just follow attention to the detail here. I know this is a bit of an unorthodox video, but I'm trying my best, so bear with me. I'm going to take my main board. I'm going to let my sensor board fly for now. And what I'm going to do is I'm just going to put a little bit of hot glue on 2 sides. And just give that a second to dry, or at least dry enough so it's not going to go flying all over the place. Obviously I'm going to want to do the other corners. There are 4 mounting holes, but I am a glue fanatic. I love glue because it's simple. It may not be the best alternative, but I am an electronics guy. I am not a mechanical guy, so bear with me. Let's just put the sensor. Oh, not long enough apparently. Let's give it one more second. I'll actually apply some glue to the lower left and lower right sides while we're waiting. And what I'm going to be doing next is taking my motor, placing it on a 45-degree angle here, and whatever 30-degree angle, so that the side mountings are in line with the addition board right here. And then what I'm going to do is I'm going to mount I'm just going to put some glue there. Don't be shy. If you're going to use glue, use glue. I'm just going to stick that on there. Now I'm going to have to wait. Again, I want to make sure that it's level. And what you can do actually is you want to make sure that the gear head is straight and in line with the addition board there. So you can just take some needle nose pliers and turn it so it's horizontal. Just gently do it. You're not going to hurt the motor. Just gently do it. Now, the next step is a tricky one. Do you see on here? Probably out of focus a bit. I apologize. There's 4 holes in the bottom. They are essentially so you can put 2 loops of wire between them and have them loop around this. Loop around the stopper or the gear head. So what I'm going to do is I'm going to solder 2 pieces of wire around that, and you can also use glue if you want, but I'm going to use both actually. So just bear with me for a second. I'm going to do some soldering and some fancy gluing. Okay, so we don't have the stopper on or the whisker, but what I've done is I've connected the motor to the sensor board via those 2 wires I was talking about and some hot glue, of course. And so this is just a test. I've also put a cable tie. If you have a cable tie, again, you can just make things neat, but leave enough slack for the wires. So when the most light is hitting the middle sensor, the motor shuts off. And when there's not enough light to actually, like if there's not much light at all, I've got a power saving algorithm in there that tells it to shut off. And right now, that is actually happening. So I'm going to use my supercapacitor flashlight. Middle sensor. Rightmost sensor. Now, because it's not overly light in here, it does shut off. We have some light coming in through the window, but what you can do is you can fiddle with the sensitivity, because now we can actually bend our sensor boards out. You see what I mean? We can bend them out, or we can bend them back in. We can bend them out just a tiny little bit. So you can really fiddle with those, and you can do it safely. There we go. It's picking up on some light towards the window. And my supercapacitor flashlight. Anyway, this is just a test. Really, the best way to test it is to fiddle with your side sensors, and to bring it outside where there's some real sunlight. So now what we have to do is we have to put our stopper on and our whiskers. And what we're going to need for that is we're going to need this wire that came along with it. So let's have a chat about that. I'm kind of casting shadows on this thing, so it's confused as to where it's looking, because there's not a significant amount of light. Anyway, I'll turn this off, and we're going to put the stoppers and the whiskers on. We're going to finish it, and then we're going to go outside and play with the sun. What you want to do is take that hard wire and take about 2 inches off it. Well, rather, cut off 2 sections of 2 inches, and you'll have a whole bunch left, and we're going to use it too. This is what's left. But what you want to do is you want to connect one to right here and one to right here. Those 2 test points are going to hold our whiskers, and you can have them facing up like antennas or out to the sides. Now these are stoppers. So what'll happen is, these whiskers, when they touch the stopper, it'll send a signal to the microprocessor saying, okay, we've gone too far this way, don't go any farther. So I'm going to solder those on right now, and you can mimic, or you can feel free to be creative, and you can also be creative about your stopper. We're going to get to the stopper in just a minute, and our stopper is our last step before we go outside. As you can see, I have placed my whiskers. Now for the stopper. Now, I've saved the best for last. This one is a little bit tricky. You see how I've taken the rest of my hard wire and I've made it into a little bit of a V shape with a flat bottom? what we want to do is put this under the wires and bring out our trusty glue gun and glue it to the back of the motor, the very back of the motor. And once it's set in place, we can adjust our stopper. But there's one more thing we have to do after that. We have to solder the stopper to ground. Now, do you remember on our sensor board there was one extra ground line? Yeah, you're going to have to get in there and just get a small wire with a little bit of slack and solder it to the stopper once it's in place. So if you want, just give me a second. I will do this. You can see what mine looks like, and you can try to mimic. So as you can see, I've got my whiskers and my stoppers on, and so if it tilts too far this way, it will stop. If it tilts too far this way, it will stop. So now I'm going to take a 9-volt battery and I'm going to plug it in, and I'm going to bring this outside. Okay, I forgot how freaking cold it is outside, so please pardon me for not going out there. I'm just going to do a flashlight demonstration. Okay, so I've been working on this for 2 hours now. There's not enough light in here for the board. It's in power saving mode right now. I've got a battery connected to it. You can use a wall transformer if you want. Forgot to press the on button. You'll see the stopper. Oh, you hit the stopper. Now it'll try again. Most light in the middle, it stops, power saving mode. Right stopper. Up. Can't go any further. And power saving mode. So it takes little steps, or I should say full steps, but one step at a time. It's constantly sampling the information being sent back by the light sensors. There are 3 analog to digital converter pins that are constantly taking that information and running it through a decoding sequence. Anyway, I hope if you have any questions, please don't hesitate to ask. You do have to get a little bit creative with this kit. It's not simply a cut and paste test or kit. You really have to you really have to show your own ingenuity here as to how you want to put it together. So thanks for watching, everyone. I hope you have a great day.